In cryptography, the one-time pad is an encryption technique that cannot be hacked, but requires the use of a single-use pre-shared key that is no smaller than the message sent. In this technique, a plaintext is paired with a random secret key, also known as a one-time pad. Then each bit or character of the plaintext is encrypted by combining it with the corresponding bit or character from the pad using Modular Edition. In this example, the method is to combine the key and the message by Modular Edition. The numerical values of corresponding message and key layers are added, and then modulo 26 is used. So if key material begins with suppose XMCKL and the message is hello, then the coding would be as follows. So we would take ASCII numbers and add them. So 7 plus 23 would be 30, 4 plus 12, 16, 11 plus 2, 13, 11 plus 10, 21, 14 plus 11, 25. So now we have message plus key. We put it, now we take modulo 26 and we have 30 divided by 26, remainder is 4. Then 16 divided by 26 is 16. And as follows 13, 21 and 24, 5. Then we convert it to letters and get E, Q, and V, Z. The ciphertext to be sent is E, Q, and V, Z. So now the receiving party uses the matching key page in the same process, but in reverse, to obtain the plaintext. And so now to obtain the plaintext, the key is being subtracted from the ciphertext, again using modular arithmetic. So now we have 4 minus 23 and get minus 19, 16 minus 12 and get 4, and so on. So we have 11, 11 and 14. So to get rid of minus 19, or if we had gotten a 0, we add 26 to our negative or 0 number, and in our case we get 7. So minus 19 plus 26, we get 7, 4, 11, 11 and 14. And now using letters, it's HELLO, so we get hello. Yes, to ensure security of our encryption, we should meet 4 conditions, and one of them is to choose uniformly and independently at random. What it means, means that shouldn't be any possibility to derive or to have some function that makes ours some sequence of numbers, but this sequence should be really, really random. So the second would be that the key must be at least as long as the plaintext. There are no possibility to somehow use statistical methods or any correlations to derive plain text. The third one is that the key shouldn't be reused in whole or in parts. And the key should be completely secret by the communicating party. So it's pretty clear why. And there is also binary version of one-time pad. And there we use it as follows. We take our bit string, for example, now we'll take as a message bit string of 10011, and we XOR it with Xor operation with the key. Our key is 00110. So what does XOR operation? It's takes it is true if so it's only true if one of the parts of statements is true. If both are true, then it's false. If both are false, it's false. So we get 1 XOR 0, it's 1, 0, 0, it's a 0, 0, 1, it's 1, and 1 XOR 1 is 0, 1, 0, 1, 1 XOR 0 is 1. So we get our ciphertext. It's 1, 0, 1, 0, 1. And the same procedure we take on the other part. So that's all to one-time pad.